Design of RCC structures, lecture 1. Okay, so let us begin it. The first word comes, which is design. So let us know very quickly what is design, why we design the structure, why we design a structure, and what are the parameters which we considered in designing. This is the basic things. First one is, first we design for safety. We want the structure to be safe. Okay. Second is for serviceability. We design a structure to give it so that it can give service to us. So I will be explaining it in detail. What third one is economy. Okay, we want our structure to be more economical. Fourth one is durability, and fifth is aesthetic. Aesthetic basically means look how it looks from outside. Okay, so by taking one example, I'm explaining all these things to you. Okay, let us take a simply supported beam carrying a UDL load. Okay, we want this, we suppose we design a structure for this loading. We design a structure, we provide certain dimension, width and depth of the beam, and we provide certain reinforcement also. Okay, okay, so why we design this beam to take this load. Suppose this load is W, anything. Okay, now we want our structure to be safe for this load. Okay, we also consider some factor of safety that will come later on. Thereafter it is serviceability. We want our structure to give service. For example, its design life is 50 years. Okay, we design a buildings generally which are having design life of 50 years. So this structure should give service for 50 years. Okay, and it should be safe equally. Okay, now the third term is economy. Economy is also very important, and we will study various methods to design. First one will be limit state method and the working stress method. We will be considering working stress method first, then we will be considering limit state method, and then we will see that which one of these method is more economical. Okay, thereafter this will come in detail. Thereafter it is durability. Suppose we are constructing a structure in a hot climate, or it is like or very cold climate, or underwater sea. So what we do, we increase the cover. There are two types of cover basically. This will also come, but here since the word has come, so I will explain here also. There are two types of cover basically. One is effective cover, which we consider from the center. This is effective cover. We cover from the center, and this one is effective depth, because we denote it by small d, and this is the total depth. Denoted by capital D. Okay, and then there is a nominal cover. Here there is a nominal cover from the outside of the bar. This one is basically known as soffit. Okay, so this is nominal cover. Okay, so for increasing the durability of the structure, in the context of durability, I was telling this. So to increase the durability of the structure, we must increase the cover for various conditions. We will see the provisions in IS 456 2000, where there is a consideration for cover and all those things that will come later on. And fifth one is also these days very important. This basically looks. Aesthetic means what? Looks from outside. This is more important from architectural point of view. These days we are constructing green building and various other modern structures in which maximum area should be exposed to sunlight, and likewise we consider various factors. So those things come under the head aesthetic. So we first I must tell you that these five different parameters should coexist for designing a structure. If we are designing anything, if we are designing RCC structure, we must see that these 5 parameters coexist. That is, none of them is less important. Each and every parameter is equally important while we are designing. Okay. Now, what we are studying, RCC structure. RCC structure. Let us know what is RCC first. Okay. So if you must be knowing this. This must be knowing this. If this is a beam, suppose this is a beam, and we are providing reinforcement. Okay, over here, and loading is done from top. Okay, when the loading is done from top, what happens is that the upper fiber gets compressed, and the lower fibers come in tension. Okay, this middle line is the neutral axis. Okay, now this bends like this. Okay, this will be the neutral axis for the bended portion. Okay, now let me change the color. Okay, now see, the upper part is in compression. These things you must be knowing it, but I'm telling for the basics for the students who are starting, just started learning RCC structure. Okay, the upper part is in compression and lower part is in, what is seeing, in tension. Okay, important point is here is that this angle is 90 degree, and here this angle is also 90 degree. Okay, this 90 degrees maintained. So since this 90 degree is maintained, this diagram, this line is linear. This line is a linear. Okay, since this 90 degree is maintained, this line is linear. Okay, since this line is linear, since this line is linear, we can say that strain diagram is linear. This is one of the assumption which will come later on. We'll study assumption in different lectures in the coming lectures. Okay, so just I want to say that concrete is what is concrete is a brittle material. Brittle is just like biscuit. Okay, concrete is a brittle material, and steel is ductile. Okay, so concrete can take compression, but concrete cannot take tension. So we are providing reinforcement in the tension side. This way must be knowing it. And steel is ductile. We'll studying this both in detail, properties of concrete and steel. Okay, so you must know from here only that this concrete is a brittle material which does not take tension. It does not take tension. Okay, and steel is a ductile material which can take tension. Okay, now we will study various properties of concrete. Before beginning a design, we will design with the help of concrete and steel. So we must know its properties. What are the properties of concrete? What are some properties of steel, which we will use in future lectures. Okay. So before starting this, you must have IS 456 2000. This is a Bible. This is Bible for you. Okay, you must know that this is a Bible for civil engineers. Okay, you must have this while you are while you are watching these lectures. You must have IS 456 2000 because I will be using it very frequently. Okay, so let us begin with the topic properties of concrete. Properties of concrete. Okay, let me change the color. So first is Young's modulus of elasticity, EC. What is EC? EC is Young's short term elastic modulus of concrete. Short term. Why is it short term? I will telling you. Why short term? I will telling you. Okay, EC is equal to 5000 under root FC Newton per mm square or MPa megapascal. Okay, what is EC? EC is 5000 under root FCK according to the code. Okay, what is this? This is short term elastic modulus of concrete. Okay, and this is what FCK. FCK is the characteristic compressive strength of concrete after 28 days of curing of cube of size 150 into 150 into 150. So these are the very basic things, you must be knowing this. Okay, so why it is short term? First of all, EC is Young's modulus of elasticity of concrete, and it is a short term elastic modulus. Why it is short term? Because we are not considering creep over here. Creep is not considered. Is not considered. We will studying creep in detail. What is creep? I will tell you in short. Creep is the strain developed in the concrete, or any structure we are considering. Creep is the strain developed in the concrete or any structure due to sustained loading. The word important is there is sustained loading, that is long term loading. It develops in years. Okay, it develops in years. When we will study creep, we will see that in detail. But here you should know that this equation, while we are writing this equation, this is not considering creep, and it is a short term elastic modulus of concrete. Okay, now another thing is FCK. We have seen the characteristic compressive strength of concrete after 28 days of curing of cube of size 150 into 150. This basically is a cube of size 150 into 150 into 150 mm. These are various cubes which we prepare from a batching plant. Now here the term batching plant has come. So in very short I would like to tell what is batching plant. What is batching plant? Batching plant is nothing but cubes of this size. Okay, we make cubes of this size. What happens is that cement, coarse aggregate and fine aggregate are mixed together to form a concrete, and then we form a cube, and then we test it on a compression testing machine. For example, if we are making M20, to be more clear, if you are making M20, it is what is this? What does that mean? Mix, that is 20. 20 is what is 20 Newton per mm square or MPa. This is its FCK value. Okay, suppose we want to make M20 concrete, and its proportion you must be knowing it, 1:2, 1:3 is cement, sand and aggregate. Okay, now you have mixed in this proportion cement, sand, aggregate in batching plant. You have weighted it. You can also do by volume, but when we weight it, it is more accurate. So I will be considering that only. Okay, 1:2, 1:3. We mix this and we prepare cubes. Of size 150 into 150. We also make cylindrical cubes, but not in India. That will come later on. I will be explaining those things. Okay, we will be comparing cylindrical and specimen and cubical specimen. Okay, so we make various cubes. Minimum 30 samples. These questions might be asked to you. Minimum 30 samples we make for testing, and we test these cubes on axial compression test. Axial compression test is done. And we test these cubes. What happens since there is no quality control, so there is less quality control at site, and concrete also is not a homogeneous material, so the strength might not come 20 Newton per mm square. It might come 21.5 Newton per mm square. It might come 22.5 Newton per mm square. Likewise, it might be less than, it might be 18, 16, anything like that. Okay, it depends upon the quality control how much you are varying from 20 Newton per mm square. Okay, it depends on the quality control that we'll be studying in equation later on, just after this. Okay, so you have come up with the result. You have tested, suppose you have tested 100 samples and you come out with these results. Okay, and now you plot a graph. Okay, plot a graph here. Here on y-axis is number of samples which you are taking, and here it is FCK. Okay, we draw a graph like this. Okay, this is known as probability density curve. Probability density curve. Okay, this value is known as FT or FM. This is the target mean strength. FT or FM, we call it as FT or FM. Okay, now let me change the color first. Suppose I am making this like this. Okay, just a second. Something like this. Okay, we are hatching this portion, and this we are telling this is A1. This is A1. Okay, okay, and this we are telling that this is equal to FCK, and these are actually at the same height. This is K into S. Okay, and this portion, and this way I'm arranging with blue with total, this total including the hatches red portion. This area is A2. Okay, this area is A2. Okay, now here A1 by A2 must be less than equal to 5%. A1 by A2 must be less than equal to 5%. Okay, how it is 5%? I'm just telling you. The basic definition of FCK, tells that not more than 5% of the test result must fall below FCK value. Okay, what does it mean? If we are taking 100 samples, suppose we have prepared over here 100 samples, suppose over here we have prepared 100 samples, then not more than 5 samples should go below, not more than 5 samples should go below 20 Newton per mm square strength. Okay, suppose this is 18, 16, then another comes 15, then another comes 10, another comes 12, then that is 1, 2, 3, 4, 5, another comes for suppose 16.5. Then this due to this 16.5 value, this whole batch of cube will not pass for M20 grade of concrete. Okay, M20 grade of concrete. Suppose I think you must be understanding this. Okay, let us move further. Now according to this graph, we can write FT is equal to FCK plus K into S. You can write from the graph. This is what? This is FCK. This is what? This whole. This is FT. Here FT is equal to FCK plus K into S. You must know S is standard deviation. You must have studied it in statistics, but what does that mean over here? From here you must know standard deviation, and S is equal to, this basically depend upon quality control. This depends upon quality control. Okay, quality control, how much you are deviating from the mean value, that depends on the quality control. That is xi minus x bar whole square under root n minus 1, where n is the number of samples. Okay, n is the number of samples. Okay, now certain value of k for the certain value of percentage probability, so certain values of percentage probability, value of k has been defined. and thereafter we will calculating for that ft. Okay, so first percentage probability, first if you think that if you imagine that percent probability is 0, then k will be infinite and value of ft will be not defined. These are certain standard percentage which we are taking. 5%, if we take percentage probability as 5%, k is equal to 1.64. what is will be ft? ft is will be equal to fck plus 1.64 into s. Okay, I'm writing this downwards. And if percentage probability is 50%, value of k is 0, value of k is 0, and values ft will be what equal to, if this k is 0, ft will be equal to fck. Okay, now what we are seeing from graph, let us analyze this. If we are increasing the value of k from if we are decreasing the value of k from infinity to 0, what is happening? First ft was infinite and then it is reduced to fck. That is what happening. Let us see from the graph what is happening. These two graphs are coming closer to it as we are moving from infinity to 0. Okay, these two graphs, this was just for analysis, so what is happening, that these two graphs are coming closer as we are increasing the percentage probability and decreasing the value of k from infinity to 0. Okay, this was just for the analysis. Okay, analysis of this graph. Thereafter there are various few terms, that is like, this is also known as sigma. Sigma is also denoted by standard deviation only. Okay, so s or sigma upon fm, what is fm or ft? This will be fm or ft. Sigma or s or fm by ft, fm or ft is known as coefficient of variation. And what is variance? Sigma is equal to under root variance. You must be knowing this. These things might be asked to you. Okay, now let us see from this here, what is quality control. What is happening? This is xi minus x bar. That is, if you are taking m20 and this is, then what will be xi? Xi will be 21.5 and x bar will be 20. 21.5 minus 20 whole square divided by number we will be doing for all these samples. Okay, I'm drawing a graph, same graph, number of samples, just fck. Okay, one of the graph is coming like this, okay, change the color. One of the graph is coming like this, and another graph coming like this. Okay, I'm going to extend this more. Okay, then which one will be the best sample? Which lot? This you plotted for one lot, blue one. Then this red one you plotted for another lot. Then this you plotted for another lot. Okay, there were 3 lots from the batching plant, and you plotted for all the lots. Then which will be the best one? Which is more closer to fck? That is, this will be good one. This will be average, and this is worst. Why? Because here quality control is good. Quality control was good in this case. Quality control was good. Quality control at site was good. Therefore, the ratio of cement sand aggregate was maintained nicely, and therefore the result obtained was closer to the result which we wanted. Okay, that is, if we wanted M20, we were closer to M20, and in this case we were farther away from M20. Okay, and in this case we were more farther away. Like over here we were there. Okay, I hope you must be understanding this. Okay, so in short, this would be a good sample, this will be average, this will be worst, because the result is more closer to the mean value. Okay, and the quality control is better in this case. Okay, that is what I was tell you. Okay, so in the next lecture, thank you for this lecture. In the next lecture we will discussing more about properties of concrete and some of the properties of steel also. Okay, so thank you very much. Thank you, students.